So we're basically creating these streams of continuation, and that's the core thing that allows us to shift back and forth between levels. So maybe before we look at the technical details, what can we do with that? So I have a tower, and now I'm starting this vertical tower, and I can do something like, let me just put out an example. So I can define some code, and maybe the code has a bug. And now if I do this, if I call thump, I jumped up one level. You can see that the 0 became a 1, and now the meta level they keep increasing because there's infinitely many of them. And I see that I expected a procedure, not 2. And you can see that the error in the code is that I'm applying foo to 2, but I'm using this f parameter, which is bound to 2 as a procedure. Okay, so I can go back to the base level. Right here. And what I can do now is basically have this inspect routine. So I think I can just evaluate the variable. So I've evaluated this inspect routine. So this is just user code, but it's using this special form delta. And delta explicitly shifts one level up. So delta says the body is going to be at the meta level, and you're going to be passed in the expressions. Here I'm just calling it with like no further expression, so this will just be empty list. You get the reified environment from the level below, and the k from the level below. And then here I'm saying that I'm creating a new inspect loop, so if I just do inspect thump, I have an inspect loop now, and I can see f, and I can see it has value 2. And that's because I looked at the reified, I looked at the argument to the inspect, looked at the environment of the closure. So this is valid in the sense that it's relying on the representations that you might have. So it would break if you change the representation of closure. And then it has this loop where it's just evaluating stuff. We're calling this meaning procedure. So this meaning is kind of like the evaluator in this level. And so now I can see that f is bound to 2, and I can set it to be a thump instead. And now I can exit the loop. And now I can just say thump, and it actually works. I completely went inside the closure and did a surgery and changed that. So either it's scary or it's nice, but it's like the kind of the importance of like the principle that push to reflection where you can do this kind of things. Yeah.
So there's 2 numbers before the prompt. I guess the first one is like the meta level that you're in. And how should we think about the second number?
So the second one is like the iteration number. And it's kind of useful to have in some sense when you're jumping around. So you jump to the meta level, and when you came back, you continued at 3. You didn't go back in time. Sometimes there are some reasons why you would go back in time, so it's good to have these numbers just for that. Yeah.
So that means like there could be like maybe more than 2 numbers in some cases, like if you have more than one, like meta level with more than one, kind of like.
Yeah. So let me just maybe show that. Up. So up is not defined, so I went to the meta level by creating an error. I could do up again and going to the meta level. I think you're right that like maybe 2 numbers is not enough to represent the extent of things, because you have like the inspect loop is kind of its own little spawn loop below the user level, and so these things are a little confusing, especially this tower is actually meta circular, so you can load the tower in the tower, and then you don't know which numbers you're dealing with. Yeah.
Do you always go up when you have an error, or is it just like?
It's just a convention, and then when I call the old count, I only use it to go back down one level.
Right.
Yeah, so this is. So it's kind of a convention that if you have an error, just pop to the meta level and try to see what's going on.
Is there a reason why?
Well, I think it's because it's like it just gives you noticed it's true in black, the tower would, like, one of the towers would work, so I just used that convention. I think it's practical, it's useful to go to the meta level to define things directly. So for example, what is interesting in, like if you look at black instead now, so in black you kind of have, whenever you're doing something, you're kind of meta-applying it and dynamically figuring out what is the evaluation function, and that's determined by the meta level. And then you can kind of like separately set band all the pieces, so being at the meta level to inspect things is just a useful thing to have. Maybe just to give a quick example of that. So I put some resources on this, but like, so for example, with this change that we had, we can even go at the meta level and change, like we can just basically, it's kind of crazy really when you think about it. You're changing the semantics by just doing set band and you're changing it here so that times, you automatically add the times in front of each number used as a function, so that you wouldn't get the error if you were. But you can do that because you have access to all these pieces of evaluators from the meta level that you can set. Yeah.
I forgot the question.
Okay. Okay, so we didn't see a few other things that I wanted to show. Maybe I'll leave them for the beginning of next time, like the proof by reflection. Maybe we can, yeah, I think it's almost time for lunch. I'm happy to just take some comments and questions in the remaining 2 minutes. Yeah.
Could you go back to the previous screen?
Yeah.
Oh, okay, I remember my question. It seems like this thing, if you verify something twice, you verify it in 2 layers, like to the meta level.
So that is kind of true for, like that is true for evaluation in the sense that if you're evaluating, well, it's kind of like, so if you have something quoted twice, you can pass it through one level, like just as data, and then it will be evaluated by the next level, something like that. So in general, when things arrive at a level, it kind of already arrives packaged as one data expression, but maybe the quotes can have distinguished between where you want the evaluation to happen. So that's kind of related to staging, where the quoting or the quoting defines where things are evaluated. So there is a bit of that. But in general, verification, if you already have data, you're just going to pass it as data up. You're not going to necessarily do something. But it's kind of maybe more complex in a heterogeneous tower, where each level is having a different language, versus a homogeneous tower where each level can make sense of what's coming from a different level.
How much would be involved in, right now this hasn't implemented comps, right?
Yeah.
Yeah.
But actually const is just a primitive, so this one has const, for example. So const is here, it's just a primitive. And I mean, I am not using closures for primitive. I am just doing this trick again of going back to the, if I have a procedure, I just do the application of that. So I'm kind of like, not really defining const especially, but just like referring to what it is in the basis. Yeah?
Could you go back to the call CC example that ends up giving us 6? I'm still confused about exactly how that works. Could you go back and
So
explain?
yeah, so basically what this is saying is that here we have times 2 whole, and that's our continuation. That will be what k is bound to metaphorically. And then when we see k, the first k we see, we jump out and do 2 times the whole is 3, so we get 6. So the thing that's tricky is that, actually, this is dependent on the evaluation order of the language. Apparently, plus, like, the first argument is evaluated first here, and this is what we do. Because in a different convention, we could have gotten 12, or 14. Does this help? Or? I think
Yeah.
the tricky part is that once we're calling this game, we're jumping out.
Gotcha,
I guess, maybe we should do that one. All right, thank you so much.